two equal resistors which are connected in series to a battery consumes electric power of 60 watt. If these resistors are now connected in parallel combination of the same battery, the electric power consumed will be, that's what we need to find out. What is the electric power consumed? You try this one, Divya, right? What's your answer?
The option C, sir, 240.
240. Let's check. And what about other two? What about the two? Not right? Okay, we'll do it. So if they are in series, so how to solve this? P naught equals to P1, P2 by P1 plus P2 equals to 60 watt. We have them connected as P1, P2, we have connected. They are equal. So current through, suppose see, simple words, if we do this. Now, if see P1 and P2 are electric power for two resistance separately, right? Now, series combination, if I add, so P equals to I square R. Okay. If I compare current I here, because in series I will be constant. Okay. So I equals to this P into V. So if I compare those, we can get simply here power. Series combination, it will be 1 by P plus 1 by P, which is 60. It's given. Now the resistance are equal if the resistance are connected in, same resistance are connected in parallel combination with the same battery. If this power is same, that means P1 equals to P2, which is 120. Double up this one. Because there are series connection. So in parallel connection, 60 plus 60, fine. Parallel connection, P equals to P1 plus P2, which is 120 plus 120, which is 240. Or we can solve this with the resistance also, not a problem. P equals to V square by R, whatever way you want. I can show you other way also. If you are not able to understand this one, then let me show you other way also. The series R plus R, which is 2R, right? This we know, everyone. In series we add. So P equals to V square by R, which is 2R here. So V square by 2R equals to 60. So V square by R equals to 120 watt. Now in parallel, R plus, no, sorry, R into R, 2 only, right? That's why R into R by R plus R, which is R by 2. So P equals to V square by R by 2. So from this one we can find V square. So P equals to 120 into 2 is 240. This value is 120. So 122 is 240. Either way, whatever way you can understand. I got both better. In this case, what I did, I just added for series and for parallel. Or we can write this method. Any method you can understand. Then this one, understood? What I did here? I just added resistance first, R plus R, which is 2R. Then P equals to V squared by R, which is 60. Okay. So V squared by R equals to 120 watt. Now for second case, it is in this combination. Again, same manner. P equals to V squared by R. Here, we need to find R for second case, which is R plus R into R by R plus R, because they are in parallel connection. R by 2. Let's substitute these values. P equals to V squared by R by 2. V squared by R is 120. 120 into 2 is 240. Clear, everyone? Any doubt? Okay. Let's go for second. Galvanometer having resistance of 20 ohm and 30 division. Now galvanometer has 20 ohm and this division. Division means 30 division. In each side there is 30, 30, 30. Each number. You tried this question? What they're saying, both side has?
Yes, sir.
Yeah, or you got this answer?
80, sir. 80 ohms. Option D.
Option D. Okay. What about the area? No? Okay, so it has 30 division on both sides. Sorry, 30 division on both sides, yes, and has a figure of 0.005 ampere per division. The resistance that should be connected in series such that it can be used as voltmeter up to 15 volt is, we need to find out that. So those who don't know, I'll just write fully. I think so all I hear 12th standard students, they know already. Okay. So 20, 30, 0.005 and 15 volt. Okay, let me remember this 20, 30, 0.005 and 15 volt. So resistance of galvanometer is 20 ohm. Number of division 30. Okay. And what is the merit here? 0.005. Figure of merit 0.005 ampere per division. In short, 0.05 amperes it adds in one division. So number of division into figure of merit. 30 into 0.005, which is 0.15 amps. This is not the answer. They're asking resistance for galvanometer. Okay. What else you need here? Resistance should be connected in series such that the voltmeter up to 15 voltage. So V is 15 voltage. R effective equals to R plus 20 ohm. V equals to IR. I is 0.15 into R plus 20. What is V here? 15.
15, sir.
So this will give you 100. 100 minus 20, which is 80 ohm. Simple. So in short, we don't need to do all this thing. I just showed you because it is first question for this, or you are doing first time. Then just simply multiply with merit. Number of division into merit. It will give you total current. This is connected in series, so 20 plus R. That is their effective resistance. It's D option, yes. Here, what are the option? Oh,
Option C, sir.
yeah. Third question. Western breach resistance PQ approximately equal R is 400, which is balanced. Pointing P and Q, the resistance R is balanced as 405. Value of X is close to what? The diagram. Okay. So for Wheatstone bridge, what do you need? Simple, very simple. P by Q equals to R by X. P equals to, what is R value? 400. 400 Q by X. In second case, 405. P by X, if we take, it's replaced because it's replaced this two. P and Q. Q by 405. So if we write this P value from above, what are we getting? Check. Q by 405 equals to Q into 400 by X square.
You have to take root of 400 into 405. Sir.
X equals to under root 400 into 405. What's square root of 405? This remove 20. Plus 5. It is 20.25 around. No, 20.05. Should be. What is square root of 405? 20 points should be.
20.12.
20.12,
12, sir. then only we can get 5 here. Okay. Around, okay, fine. 20.12. If you multiply this, what are we getting? 400. Point. What? How much? Do we have 402 or any other option? 402.5. Sir. Option C.
But these all are very, very near values. So
Yes,
let's check
sir.
our calculation perfectly. So if we don't have any other value, like if we have 4 or 10, then okay. Then we need to calculate properly. Is it 401 or 402? What are we getting? 401 or 402?
It's 402 only, sir.
402? Oh, it's 401. Let's check book answer. Oh, it says 402. It's option B there. Sorry, C, option C. But if I use calculator, it's showing different. 400 into 405. Oh, sorry, yeah, correct. 16200. Yes, 402.5, correct. Okay, it's just very easy, but just make sure you do calculation properly. These values are very near.
So if you use calculator, we are getting around 402.5. But if we do normal, like by hand, it's like 402.4.
Oh, is it? Hmm. Okay, yes, 20.125 approximate. Okay, so any doubt in this chapter? This was homework question.
No, sir.
Okay. Shall we start optics? Optics will take more time actually. Shall we start optics now? Or you want to do more question in this one? Okay, then let's start optics then. One second, just let me just open optic book. Let me refresh few topics in optics so that this class will refresh the topics. And next class will start exam questions.